Hi there, welcome to another one of our release videos. I'm Dirk Leroy, and today I'm going to showcase Integr8tor Nexus version 2026.06. As usual, I have a small PowerPoint to take us through, and if we have a look at the overview slides, this is what we have on our plate for today. There's an item on assembly panel drawing analysis, APDA as we call it for short. I will be telling you something about security levels, a new feature on the Nexus front end. Then there is an item on Angular-based Nexus clients. We continue with some of the extensions in the Nexus editors. And then finally, there is a point on QED extensions, so new items of information that you will find on the QED PDF and in the QED XML. Before we start with the panel assembly drawing analysis, allow me to quickly go here just to restart two of these jobs, this one and this one. I will come back to this at the end of the PowerPoint presentation on APDA. That's where we go. Right, if a job comes in for quoting, one of the questions that needs an answer is the one or whether the customer is going to require a single board or an assembly panel as the item that you're going to ship to him. And if it's an assembly panel, then the next question is whether you as a fabricator are allowed to make the choice of assembly panel, possibly within boundaries. Around A4 size, for instance, may be a specification of your customer, or whether it's a case that you're at the opposite extreme of the scale and where the customer has actually predefined the panel layout he wants himself, fully in full detail, the number of PCBs, the borders around it, the fiducials, anything. Now, if that is the case, another interesting question is going to be, what is the production yield on your fabrication panels for this customer-defined panel layout? And is it good or let's say better or worse than the yield that you would get using your own assembly panel sizes? So those are all items that need to get an answer. And similarly, if the outcome is going to be that you're going to deal with a customer panel, so a customer defined assembly panel layout, then really what you will need to fill out or to make the quotation accurately is some, if not all, of the items that you see listed here for your on your QED report, so after your data analysis. First and foremost, the single PCB or the single image PCB size and outline. Because even though that you're going to ship an assembly panel to your customer, the single image PCB outline is going to be a prerequisite. Many of the items on the QED report, they talk about minimum clearance, for instance, a copper pad to outline, or trace to outline, or region to outline. There is also plated hole, the smallest distance of a plated hole towards the outline. Now, if your outline is not going to be the one from the single image, but the one from the panel, all of these validations or all of these values that you have in there are basically not going to tell you what you want to know because they refer to the wrong outline. So definitely single image PCB outline is something that you will need no matter what. The same as assembly panel size. Assembly panel size is a must for calculating your panel yields, and that will play a role, of course, evidently in the price. The number of PCBs in the panel is something that probably you will get specified from your customer. Number of PCBs in X and Y, just like the clearance or the step in X and Y, is probably less of an issue at the time of quotation. Definitely they are needed for the people in CAM, but at quotation stage, that is maybe more or could be a nice to have rather than a real must. The same is true probably of the rotation, whether there are any rotated images in the assembly panel, and the rail sizes, as long as you know what the final panel dimension is. Rail sizes too are probably not that critical, but still. A lot of this information that you need, so the information from the previous slide, can come in a variety of ways. Some or all of it may be part of the email, so the text written, the email that also has the attachment with the data. There may be a number of items which are clarified or specified in there. Similarly, the customer may have chosen or decided to put PDF documents or a drawing inside the archive, which you will then get to read at the time the data is processed, and you take the information from there. But in many cases, there is also a trace of all of this information to be found in the CAD layout data. So your incoming Gerber or ODB or Eagle or whatever files, they too often contain some, if not all, of these items that we were looking for in the previous slide. And that is exactly where APDA comes in. This is basically the material that APDA is going to use to try and extract the assembly panel information that is relevant for you to make the quotation. So what we will be doing in this module is we will be going through the stack of layers and look which is which, and then try to establish if some or several of these layers contain information that pertains to the assembly panel side of things. And if so, we will try and extract this and make this available fully automatically on the QED report. Looking at this CAD layout data that has or that tries to convey a assembly panel requirement, there's basically a number of variants that you can discriminate, sorry. And the first one is the one that you see here. It's basically all PCB data is provided as single image, copper layer, solder mask, drill, and then there is inside this list of Gerber files, there is one layer, a fab drawing or a drill drawing or an assembly panel drawing, whatever you want to call it, that is going to visualize the actual need and the expected layout of the assembly panel. So in this case, the customer tries to convey that he wants a two-up assembly panel in a panel which is X and Y big, because as you can see, there is the dimensions on the panel outline. So case one, single image data, and then somewhere in the stack there is this fab layer. Case number two is what we call pre-panelized data or flat panel. And in this case, the PCB data has actually already been duplicated, and the full panel or the full-blown panel is available from the Gerber or the CAD layout data, I should say. So after reading in your Gerber file or your Eagle database or your ODB or whatever, this is the image that you're looking at. It's a biscuit 3x3 that has this PCB organized in the way that you see it organized. And although the information is duplicated in the copper layer, so the real PCB layer, so to speak, typically there will also still be an outline layer, as you see on the right, with the single image outline of the PCB repeated the way it should, and then a panel outline around it from which the rails, the borders around the single image sort of appear automatically. So that's our case number two. And case number three is somewhere in between, or a mixture of these two, you could say. It's the case where the PCB layers have a single image, so one up, the one in the bottom left image here, and in there, in the assembly panel, again, the bottom left image has the full copper details and drill details and mask and legend. But also part of the PCB layer is like a shadow outline of where the other images in the assembly panel are going to come. So it's a bit of both. It's not truly a single image, and it's not really repeated either. It's a mix of the two. But again, The single image, for instance, in this case, will only again apply to where there is copper logically. And then at the far right, there is also again an assembly panel drawing or a fab drawing, which is showing the 9-up biscuit with the panel dimensions on the outside. There's another example of the same principle here. Here, image 2 and 3 are available in the copper data as well, but they are not available in the drill data. As you can see, the drill data for this data set actually just talks or fits one of these three images, the bottom one, and then the other two are without drill data. So it's really the bottom image that can be used for design analysis. And as always, also this data set comes with an assembly panel drawing, which features the single image outlines together with a panel outline. And as you can see here, there is also the part of the routing with the sorry, with the breakout tabs. So this is, as we said, the material for our APDA module, the assembly panel drawing analysis. And what it's going to do, first of all, it's going to recognize the panel requirement automatically from one of these, from looking at one of these three variants, whether it be the single image with the drawing or these other two cases. This module at some point will realize that this is probably a data set that deals in some way with assembly panel, or that requires an assembly panel as the final product to be delivered. Once it has made that decision, or once it has found out that requirement, the next thing what it will do is it will detect the single image outline within the panel. For reasons that we said before, you simply need the single image outline if you want to have good quality QED data. It will examine then all relevant layers for assembly panel layout information, the things that you saw on the right, usually these drawings where the position of the single PCBs in the panel is drawn and then the border around it. That is going to be the next part of the exercise. That's where it will try to find and extract the information from. And if all of this works, then at the end, after data analysis, you will come out, or we will come out with an automatically detected single image PCB size and outline. You will find an assembly panel size, the dimension of the assembly panel, that we were able to detect the number of PCBs in X and Y, which we have found somewhere in there, the minimum spacing between the PCBs, the rail location, and the dimensions. The PCB size is going to sit, the single image PCB size is going to sit in your regular block that you know from the QED report. The part that deals with, or the information that deals with the assembly panel, is going to sit in the customer panel box, which many of you may already have available also on their QED PDF report. It's basically the same information box that we use when an operator up until now has created an assembly panel manually using the size editor. So in this case, what happens is the module that detects all this information from the data automatically is just going to write back its information in the existing box. But not only that, as you will see in the next slide, it's also designed to recognize and to pick up rotated and nested PCBs. As you can see here, the example, which is also live in the application in a minute, you will see it there as well. It's a sort of cooking pot, which is 180 degrees rotated. The module also handles non-regular PCB steps, for which there is also an example, which we can look at live in the queue. And last but not least, this module is going to transform all of this data to Nexus size editor mode automatically, meaning that you throw in an archive, you let it run, data analysis completes, and at the end, when you go back to your sizes editor, what you will find there is an ready-to-go panel. So not only has the module extracted the information from the different layers and written them back to the QED report, it's also creating the assembly panel as if an operator would have done it manually in the size editor. So that's actually quite neat to see, as we will find out in a minute. The benefits of this, I think they are obvious. It's fully automated and a workflow integrated process. So it runs just like the rest of your data analysis. It runs 24/7, sorry, unattended. As I said, it's part of regular data analysis. So at the time you get out, you have everything on your QED and in the relevant editors. I think the most important one is the time that this module is going to allow you to save, because as we said, it detects a single image outline automatically, which in other circumstances will have to be done manually by an operator. So taking the data into an editor to try and find out, or taking to UCAM XWE, try and see where the outline is and then define the outline from there. Similarly, the same operator would then probably also have to go to size editor to set up the panel, because you want the data about how many and the position and spacing. You want this to be part of your QED. So you would probably, or your operator would probably go to sizes editor to secondly then, after defining the single image outline, to define the assembly panel in terms of spaces and size. The fact that this is done automatically now by this APDA license is going to cut down the number of job reprocessing cycles. The two manual actions that I was describing a minute ago, outline definition and assembly panel size setup, that will require a partial rerun of the data analysis, because indeed for the single image outline, the QED values initially have been calculated towards the panel outline, which is not what you want. So after defining the single image outline, there is going to be like a sort of reprocessing of or redoing part of the design analysis to make sure that all of these values on QED now take into account the correct outline. And then similarly, after setting up the assembly panel, again, there is going to be some sort of reprocessing that is required to get the documentation in proper order and according to the state of the data. Now, since we do this with APDA, since we are doing this automatically, these rerun not only the time that an operator spends in the editors to do the work manually is going to go away, but also the time that your workflow engine spends on reprocessing this modified data. That is something that is no longer going to be there and no longer needs to be taken into account. So your workflow engine and the workflows that you have available are going to be much more available for new jobs and for other work. And last but not least, first pass data analysis on single image data is going to help you have faster job completion. If you think back of the biscuit that I was showing a couple of slides ago, the 3x3, suppose that each one of these images represents 1 megabyte of data. Then actually that whole panel would be more or less 9 megabyte of data. That would mean in the case a panel outline is detected, so without the APDA license, when a panel outline is detected, the data analysis that follows later on considers everything which is inside outline. So at that point, data analysis will be plowing through 9 megabytes of data, versus if the APDA license is installed, we get hold of the single image outline quite early in the process. And again, with this single image outline in place, design analysis will say, okay, I'll look, or I disregard, so to speak, everything which is outside outline. So rather than plowing through 9 megabytes, now in this case, there's only one megabyte of data to be examined, which in turn is going to lead to faster job completion. As benefits, clearly this is going to help you get higher throughput because you're going to have less people or less time spent on people doing things interactively, the operator choosing the outline, making the panel, but also it's going to make more efficient use of your workflows because there aren't these reruns. And in case you are a user of the dynamic panel optimizer, which is another one of our workflow engine modules. If you are using that module, DPO, then you're going to be in a position to easily compare the yield the customer-defined assembly panel layout will give you versus the yield of your own assembly panels on your fabrication panel. So that's definitely something to bear in mind as well. Maybe in a number of occasions, you are able to engage in a conversation with the customer and even persuade him to go for another option, one of the sizes, the assembly panel sizes you have suggested to him, and maybe even be able to offer him a better price. And for you, of course, enhanced material cost efficiency. Finally, there is also a note to be made on the improved QED accuracy because this APDA module will always work with the true image outline, not the envelope, as you may remember it from Cockpit Day. So if you have to do this manually, defining the single image outline, very often people might be tempted to just draw a rectangle more or less around the single image. Now, as good as this may be and as valuable as this may be, this will of course not be or not entail a very accurate analysis in terms of clearances that are related to this outline. But as I said, with APDA and with the true single image outline of the board, you will get realistic plated and copper to outline values, accurate board surface calculations, and reliable copper area results. Time to go back to the jobs that we have started. Here is our cooking pot. So this is an example of our flat panel case. The data that came in, as we see here, has been duplicated in the incoming Gerber in this case. And somewhere in this list of layers, there is this dimension.gbx, which actually contains the drawing of the panel from which APDA has then taken the information to, first of all, put this into the QED, as we said, single image outline detected, and this is its size. And then in the customer panel area, you have the size of the panel, the rails, top, bottom, left, right. Spacing is set to 0 because it's sort of nested inside each other. And then a 12 by 3 panel configuration. So in total, 36. The 12 by 3, these are the 12, which are then being considered as repeated 3 times. That's one way of looking at it, of course. So these are your 36 images in this particular panel. When I go to sizes editor, as we said, there is an assembly panel which normally would have been created manually, so that's ready to go. Nothing that needs to be done there. So that's actually quite nice to have this information not only static on paper but also in the size editor. The other one that we started here was this one, I believe, chest triangle. Similar thing. This is a case where the data comes in single image. So everything there, all the PCB layers, they are actually on single image. And then there is this artwork, a fab drawing, which is going to have the assembly panel with the 6-up with the 180-degree rotation, again, which will be, sorry, reflected in the QED results, the border, the 6-up, and then the sizes of both the single image and the panel. Those were the two that we have started at the beginning of the presentation, but as you can see, there are a number of other ones here. This is again a flat panel, so all data repeated, and as you can see, again, analyzed correctly and picked up. There is also a flex rigid, I believe, that we come out with fully automatically, like this one. So really a very nice item, a very nice module to have, which is going to help you on all these occasions that you need to have assembly panel delivered to your customer. There is one data set which I would like to have an extra look at, and that's this one. I've actually submitted it with and without the APDA license. This is the version with the APDA license. So as you can see, the single image has been identified, bottom left here. And then from there, again, the assembly panel has been created. This is another example of what we called in the presentation non-regular steps. So you have these three, and then there is bigger in Y, and then these three. So this is varying the step in Y. This is the case with APDA. This is the case without APDA. So in this case, as predicted, we are going to come out with the outline around the assembly panel, not around the single image. And as a result of this, if I scroll a little bit further here, this is the version without the APDA license, and that runs or comes out after 7 minutes 47. The other one was, I think, too lower. Yeah, this one. And as you can see, this one comes out just over 5 minutes, 5 minutes and 6 seconds to be precise. So this proves that indeed, once you have isolated the single image, the rest of the process can run much faster as well, and that your processing times, because of this module, not only will you have automatically the assembly panel information right from the start. On top of that, jobs that come as a flat panel will also run more efficiently and will require shorter processing time. So even though it's twice, okay, these are small jobs, they run quite fast. One is 5 minutes, the other one just under 8 minutes. But still, the difference between the two is quite considerable. If you would put this as a percentage, that would bring you around 30% or something. So that is definitely something not to be neglected, and that is time that your workflows are free to do other work. I think that does it for the assembly panel drawing analysis. Feel free to reach out and get in touch with commercial people or application people if you would like a trial license. That's something that can be arranged. Just let us know, and we will be happy to oblige. By the way, this assembly panel mode or option, the module, runs on the server and is basically compatible both with Cockpit and with Nexus. So even if you are still in a Cockpit environment, this feature can definitely be of benefit to you as well. On to the next one, security levels. Security is something that is on everybody's agenda and very high on everybody's agenda nowadays, whether it be banking or the social medias or I mean, there is protection and security needed and required everywhere. And the PCB fabrication, the industry, should not come as a surprise that also there this phenomenon is visible, because PCB fabrication is indeed the place where cutting edge new technologies appear, and where you have these advanced product designs and the latest and greatest from all of these high-end electronic markets like the avionics, aerospace, medicine, military, you name it. So what we have done to try and help there a little bit is this feature of security levels, and it's in basically a data security oriented client side feature, client side, because most of what you see is belonging to the front end, so the Nexus clients. It's a system of configurable, what you could call viewing permissions. Viewing permissions that can be assigned or that are to be assigned to, on the one hand, data sets, so the jobs, and on the other hand, viewing permissions that are assigned to the users. And the principle is very simple. If there is a match between the permission on the job and the permission, one of the permissions of the user, if that matches, then this job will be visible in that particular user's job queue. So this is how you use it. When a job or when an operator submits a job, he can assign this job into one of the security levels that he has been assigned with. His colleagues in the department, his co-workers that have the same security level in their account setup, they will see this job, and as a result, they will have access to it and they can work with it. People who do not have this security level, so a matching security level, the security level that matches the job, um, in the job queue of these people, this job will be absent. So it will not be visible, and as a result, of course, they cannot do anything with it. The principle is that one job can be assigned to only one security level, or if you would turn it around, so a job can only have one security level, so to speak, whereas users, they can have multiple security levels. And that is going to be, as we will see on the next slide, that is going to be the task of the admin user. First of all, he can see always all jobs. So he is allowed to have all jobs in his job queue, regardless of the security level that was assigned. So an admin user, so to speak, is above this system. It will be his task, the admin, to manage the levels, to create them, and to assign them then to the various users in line with company policies and what has been decided and must be set up. In the context of this security level feature, you will see that a number of the menus, the dialogues, for instance, for job submit or job modify, they have an extra input field where this security level can be set. And by default, or for every job that you submit, there is this default security level. And that means that it's basically unrestricted in terms of access. So everybody can access jobs in the default security level. An operator doesn't need to do anything if it's unrestricted. By default, this will be the security level that is going to be assigned by the system. So if nothing special is required, it is business as usual for the operator in terms of launching jobs. Protecting data within the integrator environment and the Nexus viewers or editors is one thing. This is done the way we just described, but of course, Nexus and integrator, they can also do exports to another file system outside of the protected environment of integrator and security levels. And for that, the export feature in integrator now comes with a new variable, called percentage sec level ID percentage. And basically that is going to make sure that whenever you make an export from one of your jobs that is in a particular security level, that this job on export is going to go to a specific folder, which will be what is defined as the group name in the security level. We will come back to this in a minute. So that this job will end up on the export side in a folder, in my case, with the name 20,000. And there it's the idea that your IT, the company's IT, is going to make sure that this folder gets the right and proper protection so that, again, only people who can have dealings with this data, that only they are allowed into this folder and be able to access the folder. So really what it does, this feature security levels, is it restricts access to certain job to a configurable group of users. You can have users with access to A and not to B, and then another group of users will have the exact opposite, and so on and so forth. For authorized users, they can see restricted viewing job in the Nexus job queue. So if there is a match between the security level of the job and the security level assigned to a user, then the job will be visible. Users without the appropriate permission, they will not see this job in their job queue. There is a default security level for jobs that do not require any particular access restriction. And for export of sensitive data, we have this, as we said, this new variable, which makes sure that it can go to a specific directory on the other file system that will then be IT protected. What does it bring as a benefit? I'm sure that this will be appreciated by your customers on their yearly audit, where you can show or demonstrate this feature, and they see or they are reassured that only a restricted group of people can deal with their data. That is certainly going to make a nice impression. Furthermore, it's uncomplicated and flexible. Flexible, up until now, we've spoken about viewing and viewing restrictions and sensitive data, but you could also imagine that this feature is used in the context of two internal departments within a company, and you just want to make sure that jobs from department A do not get in the way from the people's job in department B, and vice versa. So in that case, it's not really about high security and restricted viewing based on a customer requirement. It's just an easy method of tidying up things. And last but not least, it is of course very easy to use, as we will see in a second. At this moment, I am administrative user, so that means that if I look at my list of jobs here, there is currently 3 jobs that I see that have something else than the default security level. There is a class 2 aerospatial, a class 3 aerospatial, and an APDA Airbus. Where does that come from? Actually, this comes from here. As an admin, I can go to this users part in my setup. And here at the bottom, this item called user groups, those are basically, apart from the default security level, those are basically these 3 security levels that you have just seen assigned to a job. So each security level has been assigned to one job. And therefore, because I am admin, I am seeing all of these 3 jobs in my queue. How to add a security level is from here. You just enter a group name, which is this first one here. This is going to be used as the name of the folder during export, as we explained. In this case, I have chosen this to be numeric, but this can be alphanumeric, depending on what you want. And there is a label which is going to be this one here, the one that is shown in the user interface. So there's nothing to it really. This is how you set up these security levels. And now once you have them defined, you need to assign them to users, and the users are here in the part just above. I have user Dirk here, and if I go to modify, non-admin, so that means he is subjected, so to speak, to this system of security levels, and he's been authorized for class 2 aerospatial and class 3 aerospatial, but he's not been authorized for APDA Airbus. I have another user, which is Sven. Similarly, he's not an admin user, and for him, it's just the opposite. APDA is his security level, or the security level that has been assigned to him, but not the 2 other ones. So with this in place and these jobs in the queue, we're now going to quickly log off here. First of all, I'm going to log on as user Dirk. Dirk Leroy, non-admin user, and what do we see? 2 jobs with security level, and those are the class 2 aerospatial and the class 3 aerospatial. If I go to my add job, usual user interface, apart from this one here, where I see the default security level, which is always there, plus the 2 levels that were assigned to me in my user account by by the system admin. So when at the time I launch a job, I can actually just do nothing and then it will be visible for everybody, or I can choose one of my own security level, and that sorry, and that will make the job visible only to fellow workers that have the same security level assigned in their user account. If we log off again, and we would now go in as the other one. As expected, there is only one job with security levels here, and that's the ITAR one. So from the 3, which are basically sitting in my workflow engine, only this one is being presented to user Sven, because that happens to match his security credentials. Again, if he would go to his add job, in his case, it will only be the default and ITAR 1. Or the same thing is true, I believe, if we go to modify job, you can also modify the security level, but again, only within your own range of levels plus the default security level that can always be assigned. Yeah, so that's actually, that's it. Very simple, quite nice. This one comes without license, so feel free to have a go and try out for yourself if you want. If you need assistance, again, feel free to call upon the colleagues from the hotline. They will be happy to oblige. I think this brings us to our presentation again. And the next thing on here is an item, a very short one, on Angular. Angular, what is it? Angular is basically a framework, and it's one of the world-leading front-end design, web design frameworks. What it means is that this is basically a piece of software that goes in here in the Ucamco R&D environment. It's not directly something that you as a user will have. However, you will definitely see the benefits of us using this web design framework. It's this framework is basically focused on very complex interactive web applications. That's where it originated from, as a need to support developers on these highly complex and interactive web applications, which I'm sure you will agree, Job Manager and Job Adjuster are 2 examples of. Without going into too much technical detail, this framework has the peculiarity that it has a modular architecture, and that allows it to obtain huge performance optimizations. As you will see, once you have installed this version and you will go to your editors, it will be quite a big difference compared to the editors that you had before in terms of the performance, the speed, and the responsiveness of the user interface. So basically, it boosts an application's performance, and as a result also has very good impact and influence on the overall user experience. It's something that you will come to like before before you even know it, so to speak. Finally, this is a product that has been developed and is maintained by Google. So where does this decision come from for us to incorporate this as the basis for our clients? Well, obviously, they are web apps with a high level of functionality and interactivity. And that's exactly why this framework was invented. So it makes sense, of course, to make use of it. Our editors, they require extensive client-server data exchange. So a lot of to and froing, HTTP, visualization of data, which basically sits in memory on the server, that sort of thing. Again, it's one of the, it's the ideal playground, as it were, for Angular to do its work. These editors, they also have a complex network of inter-application links and dependencies. So if you think of a job adjuster, if you go in one editor, it's going to have an impact on somewhere else, other pieces of information. So that all needs to be synchronized and needs to be synchronized very fast and needs to be up to date all the time. So there too, you're going to see the benefit from this Angular application, which has been used for the new generation of of our front-end clients. And then even though they are still the web applications, sometimes you tend to forget, but Job Adjuster, Nexus Job Adjuster and Job Manager are still, between quotes, simple web applications. But because of the work that they have to do, the functionality that they have, and the possibilities that they need to bring to the user, our users expect a desktop grade level of performance, I would say. So as if you would be using a normal application which is installed on your desktop and which you use directly if you were, rather than having a browser in which there is this application running. So the only important question is, what does it bring to you as a user? Well, I think it's next to the green arrow there. It's a feeling of keeping up because of this, the enhanced responsiveness that comes with the Angular version of our editors. You actually have a feeling that the machine, that the application is keeping up with what you're doing, rather than you having to wait for the application to come back to its senses, so to speak, or to come back with the result. There's no fun in clicking something and having to wait. Only if it's half a second that you have this latency between a click and something that you see happening on the screen. It's simply much better if you can do this in real time, or in the same fraction of a second, so to speak. So this is one aspect, the fact that you're going to love the speed and the responsiveness of these applications. But there is also something in the wake of this, and that is because you have a much more robust application now. We are able now and in future to come up with more sophisticated functionality for our editors. And that's something that in this release we've already done for the outline editor, the hotspot editor, and the sizes editor. As you will see in a minute when we come to the next chapter, which is just exactly about these Nexus client extensions. But before we go there, let me just give you, here is one that we will use for the outline editor. So that's one over here. It's quite, it's not exaggerated, or how should I say? It's not a real big board, but still it can do for the example. So this is one image here at the bottom. If I would take this one in layers editor, for instance, you see already that actually the drawing or the setting up of the layer editor, that is something that goes really fast. And if I start changing or clicking through these layers, or I make zooms, and then I start doing what is it? Here, the move image, the zoom out via the scroll wheel. It's actually, yeah, it's instantaneous, and so it's really in the moment. So as soon as you do your zoom in, your zoom out, it's actually very pleasant to work with. It's something that you get used to, as I said, before you actually know it. So I hope you will appreciate that part of of our application, the fact that using this Angular technology or building it in, we have now been able to provide you with a much more pleasant user interface. I'm going to go back to the presentation just to have them on the video recording, because most of what is here now is something that we will do in the live application. But just running over a number of these Nexus extensions. We have in Hotspot a number of new things. One of them is a mode selector, which is very nice, which I will show in a minute. The smallest value display column, the hide empty checks possibilities. Then for the outline editor, we've been working on dealing with outline candidates and selecting data from one layer. If you need to make an outline layer yourself, for instance, you may want to be able to select some chain in one layer and then copy it to a newly created outline layer for the system is something that we will demonstrate in a minute. Drawing area behavior, click 1, click 2, also that you will see what is meant with this. It's actually very nice, very pleasant to work with. Again, there is a new measure between numbers function, suspend active function using the space bar in case you're working on large data set, large in the sense X and Y dimension. And you need to zoom in on one corner and then go and do something else in the other corner, that sort of thing. We've also reworked the snap function so that it's much more stickier, I would say. In sizes editor, there is of course this thing with the APDA mode, which we already saw a bit of. But there is also these auto calculation modes and the repeat direction arrows, and then there is a number of miscellaneous items. I will take you through some of them. So that is, I believe, the moment where we want to go back to the application. And the first thing that we had in there was the hotspot viewer. And if I go and pick, for instance, this circuit, and we go to the hotspot viewer, what you will have now is in this area where you scroll through the errors, there is this mode selector. And if you open it, it's a list with 3 items. One is called check range layer. The other one is check layer range. And then the last one, layer check range. And it's basically, you could look upon it as a sort of pivoting mechanism, different ways to look at the design analysis results that have come out of the integrated design analysis. The first one here, the top, is basically the one that you know from time immemorial. That was the default one up until now, and also the only one up until now. What it does is it invites you to first select a check, copper width. Then, if you want, go and select a range, this range. And then finally, again, if you want, select the layer of interest. Now, already in this state, you see that after selecting the check and selecting the range, this stack up has changed appearance in the sense that a number of layers have been dimmed. And there is this little counter box here in front of most of these layers, or on some of these layers. This stack up basically takes over the functionality from the traditional bar chart here at the bottom, where you can also go and select the different layers by layer. So what you see here is the representation of the layer names and the number of errors that they have. But this, frankly, I find much more appealing. You immediately see which layers are of no interest to you. And then for the layers that are of interest, you get to see how many of these errors there are. So if I would now go here and say, I'm interested to see this one, then you get your 1 of 1. And that's basically what you've done. So you could then go and this one and this one. And as soon as you have made your selection, you can start clicking through them. That is a system that you're familiar with. The second one is same principle, but now the order of things is a little bit different. Now you're saying, I'm interested in everything that has a critical trace width problem. Check. And then your next question is layer. So now you're asking to be shown critical trace width, for instance, on my layer 1. As you can see, there is no critical trace width on 2 and 3, and also on layer 5, there is no issue with this. So first the check, then the layer, then the range. Again, you could leave it without the range, and if you click it, of course, in this case there is only one range. It wouldn't make a difference. Maybe one of these others has different ones. Yes, a small one and a big one. Mind you, or please note that also depending on the mode that you have chosen here, there is this 1, 2, 3, which is going to change place. I'm going to go back to the first one. So now I have my 1 here. The range has the 2 and the layer has the 3. In this configuration, check stays number 1. Now layer is 2 and range is 3. And if I go to the last one, layer will be the first. So if I switch to this last mode, I'm actually looking at my analysis results from a layer point of view. Tell me everything that relates to copper layer 1, or tell me everything that has to do with drill layer such and such. Yeah. And then after I have clicked the layer, I am then invited to further specify the check. So in case of a drill layer, I could say I want to see everything that has to do with rings, for instance, for this particular layer, and then go from there. One range, in this case, between the 140 and 160 micron. So that's the idea, basically, that you have different ways of viewing the same error data. It will keep, or it will note the one that you last use. So whenever you come back, you will be starting with the mode that you left with in the previous review of a job. Furthermore, in this hotspot editor, we said that this column here is new. This is the smallest value. So whenever you have a check and your filtering has been done, you will have a count here, which used to be there also in earlier versions. But the smallest value is telling you, okay, for this particular check, your smallest value, so critical copper width on your layer 1 here is 125 micron. So that's kind of nice. In this way, just by scrolling through this list, you see whether or not it's basically useful to go and look at individual hotspots in the data. If you see that everything is okay here or above a certain value, then that's fine with you, and then you can skip this stage. Also interesting is, maybe I can see if I move back to here. Do I get something here? I'm looking for a case. Sometimes you have these count 0. And what we have as an additional feature is, you see there is this filtering mechanism here. If you, it was pressed, probably that's why I didn't see, of course. So now I just deactivated it. And in this state, when it's deactivated, basically every single one of the checks will appear. If you activate it, you will be hiding the ones that have nothing to show. So there is no hole in SMD or hole in BGA in this job. So if I would click this filter, I will only be left with, let's say, the relevant bits. So mode selector, and then the minimum value per check plus the filter to filter out the checks that do not have any relevant thing. That's for the hotspot editor. Outline editor was also something that we mentioned. If we, in the context of more sophisticated functionality, if we take this job again and we go to outline editor, first of all, what you will see here is we have extended our effort to support you on image outline candidates. If you click on one of these 3 layers, you may see 3 outline candidates. Those are outline shapes that we have in the course of the process, and looking at everything that is available. Those, in this case, are 3 potential shapes that could represent the outline of the board. And very simply, if you agree with one of them, if you say, I want this or I want this, what you do is you just tick here the single image PCB, and that will make this one as the one and only candidate for the board. Basically, the image candidate 1 is always the one which we have assigned to the job by default. So, sorry. In this case, as you can see, the board outline, the board outline is correct, so I don't need to go in there and basically have a look at the other ones. If that is okay, that's fine. But there was this other one here, remember, where we had run without the APDA license, and now as a result of that, the outline is the one around the assembly panel. So what I can do here now is I go back into this outline editor. And in this particular case, I will see, or you will see that there is an outline for the single image, basically in every one of these copper layers, or I should say in every one of these PCB layers, because they're also sitting in the mask and in the silk and in the bottom. So what I would like to do now is somehow tell the system that this line here, which goes around the board, that is basically the outline that I'm interested in for my jobs. So what I do is make sure that the layer that you want to start from must have this red block on it. Yeah, I'll show you what I mean. Now this layer is visible, but it doesn't have the red block. And in the absence of the red block, the functionality here for the outline editor will be disabled. So you need to click somewhere over here, and then you will see that these functions become available. Now, what is it that we're going to do? The candidate here, as I said, it's the one that we have assigned by default, is the big one around the panel. This is for the case at hand. This is not what we want. So I have made, I'm going to hide it for easier selection. I have made this the red block, and now I'm going to add an outline layer. It's going to be created down here. And next thing what I will do is I will use some of these selection functions. Here you have a plus or minus to select or deselect. So add selections or subtract selections if you selected so much, something too much. And then you have a number of controls here that will define the type of selection. And the one that I'm interested in here is the select chained. So if I go here and I click on the select chained, I see that apart from this little arc here, the whole chain is being selected. So what I do next is maybe I zoom in a little bit and I add this piece to it. Can go back to total view. And now with this item being selected, what I have here is a function that will copy the selected items to the outline layer. So if I click this one, you will see it turn blue, and turn blue. Blue is always good. Blue means that the system has registered this, that you wanted this chain of vectors to become the job outline. It has confirmed and acknowledged that by putting it into blue. And then if you would now go close and reprocess, that will take this job away. And later on, we will see that it's hopefully that it has changed the outline to the to the single image. No, that was a joke. My system is currently equipped with an APDA license, and as you will see, once the single image outline is in place, so yes, now I have defined it manually, true, but now with the APDA license in place, we will again restart the routine where we say, okay, if this is the single image outline of the board, let's go and look in all of these other layers to see if we find something that resembles an assembly panel drawing, and if we do, we will still come out with the assembly panel and all of the information that goes with it. The same could be done here. If you wanted, you could take this one to outline as well and repeat the same thing. So the candidate here is what we saw, the one around the complete panel. You could do the same exercise if you first find a layer where you can pick the single image outline, this one here from, put it in red, and then do the same hocus pocus. That should be okay. We may come back to this one later on, but you already see it's gone through the process of regenerating the image, and then now indeed the single image outline is what I want it to be. And then later on, when the analysis has completed, we can have a look at the QED. So that's for the outline editor. While this is doing the rest, maybe we can go here to have a look at the new features on the drawing area. So a number of these editors here, they have the drawing area in which the data is visualized. And what we have here is a number of things I could use here. Yes, first of all, there is this new function, measure between points, that is combinable with this snap. So that is really nice. This is the sticky snap I was talking about, and this is the click drag behavior. So I think in previous versions of the editor, what you would do is you would click and you would hold the mouse button from point 1 to point 2. This has been changed, and now it goes from click 1 to click 2. And why have we done this? Well, I'll quickly show you, because it makes it much easier. Suppose that you wanted to, I'm inventing here, but suppose that you wanted to measure from here something small and not so easy to see to somewhere else. What you can do now, or what we can do now with this behavior, is I just say here, let's do the same measure. I don't know what it's, oops. So I click my first point and out comes my little triangle. And now what happens if I press the spacebar? I'm sort of suspending this measure function, and I'm able, with the spacebar pressed, I'm doing this, or I go to fit screen, and then I do a rectangle zoom. Sorry, a rectangle zoom. And when I let go of the, oh, did I miss it? I missed it, sorry. That's my mistake. Hold on, we do this again. I'm going to go here and do the measure it was with the snap. I do this, out comes the triangle, and now if I start running about, as soon as I let go of the spacebar, you see that the measure points takes back control. And this is what we have. We have the X offset, the Y offset, the diagonal, which is basically repeated also here in this yellow box, the start, the end, the X, the Y, and then the diagonal. If not, you can still use the other functions that we had before for measuring, which is the measuring for the clearance, where the embedded snap function here too is going to be much better than before. So that too has benefited from an overhaul. And then there was the other one here, where it goes center to center rather than the clearance. Okay, fit screen. So that was the click 1 and the click 2 behavior with the spacebar that allows you to do change viewport in between. We had the measure function, the new measure function between points, and then the sticky snap. I think that can get us out of this one here. Maybe in the meantime, which one was it that we have relaunched? This one has completed by now, and if all goes well, you see already by the image on the QED, we have detected there is one in full print and there is one in dimmed display. So we have actually detected the assembly panel with the rails and relevant information going into this here. So just by defining the correct single image outline, we were able to pick up the assembly panel information from there. Back to the other one, we were saying something about sizes editor. If I pick on an item which has gone through assembly panel, you will see that all of these the images that are supposed to be part of the assembly panel, are in place automatically by virtue of this APDA license. You notice here that the outline dimensions currently have been made part of the sizes editor, which is quite handy for the work that you have to do here. And the other new part here in the middle is this assembly panel definition, where you have a choice of 1, 2, 3, 4 items. APDA is the one that comes with the module. So if it's being created automatically, then you have the information from the automatic module. You have the values here, but they are dimmed, so you cannot edit them. If you want to make panels yourself, maybe the information was just in the email, please provide assembly panel with blah, blah, blah. Then there is a number of 3 new ways of creating the panel. It's basically a further evolution of what we had so far. In this case, what we do is, depending on which mode you select here, there is always one thing that we will do for you. So in this case, it says auto calculate the panel size. That means that you will set up the number of PCBs in X and Y, you will set up some spacing, and you will define the borders, and that will give you your panel size. Similarly, if you check this one, then it's we who are going to calculate the spacing and the step on the basis of the other information that you have provided to us. And then finally, there's the auto calculate borders, which, as you could guess, is us going to fill out the border values automatically based on the other items. And I'll show you when or where this is interesting. You see this one here. Sometimes you get these drawings where you see a PCB, a sketch of a PCB sitting inside of an assembly panel. And like in this case, the only dimension that you have is a panel dimension size, X and Y, but there is nothing in terms of what's the border here, what's the material, nor is there anything about the size of the PCB itself. And if there were, then you would have probably, you would take your calculator and then work out from the size of the panel versus the size of the PCB, what left and right and top and bottom could be. So this is a nice example of a case where these enhanced possibilities for manually creating a panel come in nicely. In the case that we just saw, you would switch to auto calculate borders. You would say it's 1 by 1, and you would define the panel size from here. And then because it's just a one up, you wouldn't need a step or a space. And then the rest would be calculated here automatically. The repeat arrows here in the size editor is for the case where if you have, let's say, a 4 by 5 in a drawing somewhere, and you're not able to pick on the lower left image for some reason, the outline isn't there yet, or the outline is not on that particular image, or the outline chain is not complete, or it's not good, or it doesn't roll up, and basically one of the other image, which is not bottom left, would do the job. And basically you can now add, for instance, bottom right or top left and right, and then indicate from here that the direction that you want to go is right to left instead of left to right, or top to bottom instead of bottom to top. And that will make sure that your images are still okay on the QED report. Going to bail out and quit here. What were the other ones that we mentioned during the presentation? There is a text spec editor. Text spec editor used to have two views, a parameter view and an AI extract view, and they have been merged together. So your text spec editor will look like this. And in case you have an AI extract license, there will be extra lines here in which the value from the AI extraction will be displayed. But this is a much more convenient and nice, and I think more compact and user-friendly user interface that will help you through the capturing of your product parameters. You may have noticed that every now and then there is this pop-up that comes here. Those are the notifications that have been introduced in this version. So here you have an overview of jobs that have been started, jobs that have been stopped, or what you have done to them. A clear all will get you rid of this. And I believe, if I'm not mistaken, there is also the possibility to play a sound whenever they pop up. The help tour is in a part or in a number of the a number of areas in the user interface. You will see these question marks, and basically they are a quick what is this sort of online help. So it's if you're new to the product or if you have to train new people, that is something that might come in handy, or in their first sort of days and weeks. If they are still a bit lost, it can be of help to talk people through. There is more than just this, as you can see with each click that you do. If you do a fresh installation on a system, the first time that you come in here, you will be presented with one of those. If you already know your way around, you just click it away, and that's the end of the story. A very nice one as a next is something that finds is maybe not on this job. Let's see, there was one with some more layers. Yes, this one. Let's take this one to layers editor. If you need to fill in values, for instance, here, or another example is in the drill editor, we now have a feature where you can actually say, okay, it's going to be an 017, and as soon as you click and you drag down, you're going to duplicate these values. So if your outers were 35, then you just have to change these to 35, which is, in the case of high layer count jobs, much more convenient, I believe, than having to type them one by one. As long as we are in the layer editor here, I want to show you, this is it. These lists, whether it be the function, I mean, it's typically used on the function. This is now, these lists are searchable. So if I've just pressed the letter D and it jumps to the first one that starts with D, another press will do the next one with D, the next one, the next one, the next one, the next one. Yeah, so that's quite easy, rather than if you have to scroll through this list each time and then try to read it, you do the initial letter of what you're looking for one time or a couple of times, and that will get you going. Maybe you have noticed at the time that I was changing users, but this one has returned. So this used to be there in Cockpit, but in Nexus we had to do without for some time. So we have introduced this, and you will be advised in this area of any imminent new releases or something worth noticing can be displayed in here. There is, if I go back, for people who are set up in a cloud environment, we have now a download function to copy your original job or clean job or whatever, to copy that through your to your local system. Because in a real cloud environment where you are with the service provider, of course, accessing the exported folder where your data resides, because it's in a cloud and on a completely different environment, is not an easy thing to do. So what you do is you go to your as an admin again, you go to your settings, and in the output section, you will see here a new part, which is download. So for the moment, I only have download the original job in DPF format. But if you would go and look in here, this is basically the same list as you would have in the exports as you know them from normal file export. The tour, because it's my first time that I have opened this on this particular version. So that was the download. As long as we were here, and maybe you already noticed when we were talking about these security levels, but we've also been working on some password reinforcement rules. So you can set up a system that is going to force a password change after X amount of days and the amount of days you put in here, or you can make something which is compliant, ISO 27001 compliant, and that means that your passwords will have to be or will have to have a certain length, uppercase, lowercase, special symbols, extras, that sort of thing. So if you take that one on, then the passwords that you use for your Nexus access will be verified to comply with this. And then finally, the last one, I think, is in here with our solder mask color, where you will now also find a brown solder mask color to be used on your data sets. I think we have done the tour from the additions in Nexus. The last thing that I want to do, and briefly just here on the presentation side, is a number of add-ons that we have put in the QED reports. So not on the editors, but really in the QED PDF and XML reports. One of them is a copper sidewall area calculation. Copper surfaces free of solder mask, they exist, of course, in an XY space, the flat thing. But of course, also the copper that stands up from the prepreg or from the laminate that stands up, if it's free of solder mask, that's also an area that is going to take surface finish. And depending on type of surface finish and the amount of that exposed area, this can be quite a bit. Particularly if you're into these heavy copper applications where rather than microns or half ounce or ounce, you're talking about things like 10, 20, 30 ounce thick copper. As you can see here in this picture, the amount of free of solder mask copper area can become quite important. And so what we have done is for each run that you do in the same area where you will find the QED free of copper, the surface area calculation, there is now also associated to this this particular part here, the copper areas, copper sidewall. So for the top and bottom layers, the outers, obviously, because it's free of solder mask, what we will do is we will calculate the wall length. So that's the running millimeters, so to speak, in this case, of all these edges. So these Z items that, yeah, the combined length of all of them, so that when you set up a copper thickness in one of the editors, like 35 micron, that will then be calculated to some sort of wall area. We've chosen this to be in 2 values because that gives you the possibility to actually just let standard design analysis run. That will always give you the wall length free of solder mask. And then in your quotation engine, you may still have or you have the freedom there to define the copper thickness in your quotation engine rather than on Integr8tor, and that would save you a partial rerun on Integr8tor. So if you just say we will go with just the length and calculate this into the surface in the quotation engine, that's just as fine as well. This is unlicensed, so you will see this appear as soon as you have your version installed. The other one is the copper area calculation in case of filled vias. Up until now, we were making abstraction of vias that were filled, be it with solder mask, with resin, or copper. But of course, once a via is filled, it doesn't have any battle surface anymore. And as it doesn't have any battle surface anymore, it's also an area that is not going to take surface finish. So again, the context is a surface finish, and the cost of the surface finish, definitely the ones that are gold based, like the ENI and then gold itself, given the prices or the price of the resource, that is becoming increasingly important. So once you have in your drill editor, you can set per tool, that is something that we've had for a long time, but per tool you can actually say whether it's going to be filled or not. And if a tool has been declared as filled, it's going to be left out for this particular part of the copper area calculation. So the area free of copper will not be, or they will not be included in this value. Item number 3 is the possibility to have multiple conditional formatting files set up. Conditional formatting is this system that will make what you see here in the bottom, that will make these cells red. And up until now, there was only one set of rules that you could apply. And it was always these rules that would be responsible for turning certain cells from no background to a red background. But as you are able to set up different QED reports, that's something also that we have done for a very long time. You might be in a position where a certain QED report is going to person A, your customer, but then another QED that you have generated may have less or more information and goes to internal for your own resources, for people in engineering or what not. And then they might have need or first of all, maybe for more information, but also the rules that are used for making cells red could be different than what you would use maybe for your customer, if at all you do something in terms of conditional formatting for your customer. But so in this particular context, it is, of course, very useful to be able to format one report according to one set of rules and another report according to another set of rules. And that's exactly what this is, what this new feature allows you to do. So in the settings where you set up your QED report, where you define all of these things, what goes on it, there is now this new entry here, which says conditional formatting file. And mind you, it's file. So the only thing that you give in is a file name .xml, not the complete path. It's just the file name because all of this resides on the server and we know where this thing sits on the server. This is an extension to that will make those of you happy who are using, the email submit feature. Sometimes when an email comes in, email with attachment that has to go to Integr8tor, you know that we have this possibility to submit data to Integr8tor via email. Up until now, we made abstraction of any images that were sitting in the incoming mail. So if the mail from your customer happened to have a screenshot from an Excel sheet that he dumped in there, that was information that was not passed on to Integr8tor. And at the time the job was processed in Integr8tor, Nexus Cockpit, whatever, if you clicked on the entry, that image that was sitting in the original email is no longer there. And as it can contain potentially vital and important information, that's something that we decide to have travel along with the rest. So when the email has been submitted to Integr8tor and you click on the entry in the job queue list, you will now also see whatever image was included in the original one. And then this is the last one. I think, if I'm not mistaken, we have been adding, and that's only QED XML, not on PDF, but in QED XML, upon request of a number of our users, we have been adding an extra piece of information that will tell us if that will tell you if an incoming archive was containing multiple formats. So sometimes you have these archives where both ODB and Gerber are supplied. And then this case will now be registered in the QED XML. So we will say the incoming archive had this and this format present in the archive. And this is the format that was used in the end for the data analysis part in Integr8tor. The code fixes, you will find them on the release page when you click the link, and you can read them. You can read them from there. There's quite a few of them, I can already tell you, and many of them again have to do with better or improved behavior of the user interface or individual functions inside the user interface. I think that brings us to the end of what I wanted to show and tell you. Again, feel free to reach out if you have any questions. Contact your local sales or application people. They will be happy to help out. Thank you for watching this video. See you next time. Bye-bye.